Hello everybody, this is the Math Hub, and today we're going to be going over Unit 1, Lesson 2, Order of Operations and Evaluating Expressions. Okay, so one of the key focuses of this lesson are powers. Now, what is a power? Well, a power has two key components in it. It has an exponent and it has a base. And what we're going to try to do is evaluate these powers and simplify them into a single number. Now, how do we do that? How do we simplify a power into a single number? We are going to be multiplying the base by itself according to how many times the exponent reads. I will say that one more time. I know it was a lot. We are going to multiply the base by itself according to how the exponent reads. So let's do an example. Let's use the power 3 squared. That is an example of an entire power. But what we want to do is we want to convert this into one single number. So we have to figure out which of these numbers is which of these instances. The base is always the number that's going to be the larger one on the bottom. So that would mean the base is 3. The exponent is always the smaller number on the top right. So in this particular power, the exponent is 2. And remember what I said. We are going to multiply the base by itself according to how many times the exponent reads. So the base is 3. And we're going to multiply it by itself. So we're going to multiply it by 3. But the exponent is telling us how many times we have to multiply it by 3. The exponent is 2. That means we're going to multiply the base 2 times. So our answer is 3 times 3, which equals 9. All right, so now we get to use that information we just learned about powers, and we get to try to solve some of these questions. So we have 3 examples here. Pause the video, try to solve them on your own, and I'm going to be answering them. All right, so the first one, 5 squared. 5 to the second power. You can say it either way. 5 squared, 5 to the second power. It means the same thing. Same with this one. 2 cubed or 2 to the third power. Those all mean the same expression here. So the first one, 5 squared. Which one of these numbers here is our base? That's going to be 5. Which one of these is our exponent? 2. What's the rule here? Remember, we are going to be multiplying the base, 5, by itself according to how many times the exponent reads. We're going to be multiplying the base, which is 5, by itself 2 times. 5 times 5 equals 25. Next question. What's our base? It's 2. Exponent is 3. We're going to be multiplying the base by how many times the exponent reads. The exponent's 3. We're going to have 3 2's right here. You can all do this in one if you know how to. If you don't, just do one at a time. 2 times 2, that's 4. Still got to multiply it by one more 2. It equals 8. Finally, we have a fraction here, 3/4. That's still our entire base. That is still one number. And then we have 2, which is our exponent. Do not get fooled by this fraction here. We're going to be using this exact same process when we're trying to evaluate these. So we're going to be multiplying the base, 3/4, by how many times the exponent reads. It's 2 times 3/4. Do we remember how to multiply fractions? You can try to simplify these using the cross method. Nothing can really be simplified here. So we just multiply straight across. 3 times 3, that's 9. 4 times 4, that's 16. Our answer, 9/16. Now we're going to be getting into the order of operations when we're solving some of these larger problems that require use of a lot of different operations, which include possibly some subtraction with some multiplication, and maybe there's even an exponent in there. Maybe there's a power. So, a key abbreviation we can use to help us solve these large equations is what's called PEMDAS. Now, this is extremely helpful because it gives you sort of a roadmap as to which thing you're supposed to do first, because it can sort of be overwhelming when you're solving these problems. It's nice to have an idea of what you're supposed to do first. So, we're going to go over what each of these letters mean in this sort of word here. So the first letter, P, that stands for parentheses. Anything in a parentheses, you always solve first, no matter what. Next is the E. It stands for exponent. Whenever there's an exponent, as long as there's no parentheses, you're going to be doing that first. Next is multiplication. So you're going to do multiplication after these two, but before the rest. Next, division. Do all four of these things before the last two, which is addition and subtraction. Always do addition and subtraction last when you're solving these larger problems. Okay, so now we're going to be using that information we just learned to help us solve these bigger questions that include many different forms of operations. So, these are questions to where it gives you what each variable equates to. And what we're going to do is we're going to have to plug these values in for the variable and then use PEMDAS, our order of operations, in order to solve them. So, for example, for this first one, we're going to be plugging 3 in for every single x that we see in this question. So it's going to be 3 right here and a 3 right here. And we're going to be plugging in 4 for every y value we see. So that's going to be right here. Pause the video, solve these if you can, and I'm going to be solving them right now. Okay, the first question. What I recommend doing here is plugging everything in and then using PEMDAS after. I wouldn't only plug in some of it. I would plug in all of it and then solve. So I'm going to start by plugging in everything. So plugging in 3 for x, that's going to be 3 squared plus 2. Have those parentheses. Plugging in 3 for x, that's going to be 3 plus plugging in 4 for y, that's going to be 4. There we go. We have our expression. Now we have to use the order of operations. So what's the first thing we have to do here? We have to solve the parentheses. So anything inside the parentheses we have to do first. So that's going to be 3 plus 4. That's 7. So let's do 3 squared plus 2 times 7. Next is your exponents. So remember, we're going to have to be using those power rules in order to solve these questions. So what's our base? It's 3. What's our exponent? It's 2. You can work to the side if you have to. We're going to be multiplying the base by however many times the exponent reads. We're multiplying it by itself 2 times. So it's 3 times 3 equals 9. So we have this all equals 9 plus 2 times 7. So now we have 9 times 2 plus 7. 9 plus 2 times 7. So what's our next thing in the order of operations? It's multiplication. So we have to multiply this before we add this 9 plus 2. So that equals 9 plus 2 times 7, 14. And finally, we just got simple addition here. 9 plus 14, that equals 23. That's our answer for this question. Second question, we have x times y, all of that in parentheses, and it's cubed. We're going to be plugging in 3 for x and y for 4. Plug in everything first. So we have 3 for x, 4 for y. We're going to be multiplying that, and we're going to cube everything. So I see parentheses here, so I know that's going to be the first thing we do. So anything in these parentheses, 3 times 4, that's 12. We have 12 cubed. It's a big one. You guys got to be ready for these big ones. What's our base? It's 12. How many times are we going to be multiplying the base by itself? 3 times. So we have 12 times 12 times 12. And solving 12 times 12 once gives you 144. And we're going to be multiplying that by 12 again. 144 times 12 is 1,728. And that is your answer. Last question here. 4x squared minus 3xy. We're going to be plugging in everything first. Let me just make it a little bit more separated so you guys can make sure you can see it. Okay. Plug in everything first. 3 squared minus 3. Plug in 3 for x. 3. We're going to be plugging in 4 for y. 4. I don't see any parentheses that we are going to be solving to begin this. There's nothing here we can evaluate. Everything inside the parentheses is already simplified to the most. So, the next thing we're going to be doing in PEMDAS, it's exponents. So we have our base of 3, going to be multiplying the base by itself 2 times. 3 times 3 is 9. Remember, if you need to work it out outside of the problem, that is perfectly fine. So we have 4 times 9 minus 3 times 3 times 4. So it looks like we have a whole lot of multiplication here. And that's exactly what we're going to be doing. We're going to be solving out all of these multiplication before we end with the subtraction. So let's do all this multiplication. 4 times 9, that's 36. We're going to reduce 36 by 3 times 3, which is 9. 9 times 4, 36. 36 minus 36 equals 0. And that's it. Your answer is 0. That is going to be it for this lesson, everyone. Make sure to comment if you have any questions. I will certainly answer, and I'll see you in the next one.